All right, so this section's on polynomial and rational inequalities. These can be a little bit tricky, I think, but I think if you're pretty comfortable with graphs, then they are actually pretty simple. So we have some. This is a step-by-step way to do these that I got from the book. I'm not going to follow this exactly, although you can if you want, and maybe I'll show one example for how to do this in this way, in case you prefer that to the graph. But I really think that graphing is the easiest way to do it. So the first step, either way, is to get everything on one side. And we'll have this is greater than or equal to 0. The zeros are, so if we factored this, it would look like that. We won't go through that. And so now what we can do is we can plot the zeros and get a basic shape of this. So we have -3, 1/2, and 2. And then the other part that we need to pay attention to is this is an odd degree polynomial. This is a positive leading coefficient. And so this graph, like we learned a couple of sections ago, is going to look like that. Essentially, at least on the ends. So we know it's going to come up like this. These are all, because this is a cubic, we have 3 distinct zeros. So they're all multiplicity 1, which means they're all going to cross the x-axis. It's going to come like that and come through like that and then come up. And so that's the basic shape of the graph. We're not really worried about how far up or down it goes. Just where does it cross and then which direction is it going on the end. That's really all we need to know. So the greater than or equal to 0, we're looking at where this line is at or above the x-axis. And so we can pretty easily tell that it's between these two numbers. So that'd be between -3 and 1/2, and then also after 2. And so that is the answer. And I think that's a pretty easy way to do these as long as you're comfortable with the graphing. If you're not comfortable with the graphing, then you got to do something else. And this something else, if we write this in the factored form using the zeros, this would be x plus 3, 2x minus 1, and x minus 2. So that would be the factored form of this. And then what you could do is we can pick numbers that are between each of these or outside each of those. So say -infinity to -3, let's pick like -4. And then between -3 and 1/2, let's pick 0. So this is called your test point. And then between 1/2 and 2, and then between 2 and infinity. So we could pick 1 for that interval. We could pick 3 for this interval. It doesn't matter what you pick. I would pick the easiest number that happens to be in the interval. And then we're just going to see, plug those numbers in here and then see if it's positive or negative. So if we plug in -4, -4 plus 3 is negative. 2 times -4 minus 1 is negative, and then with the parentheses, or negative number times negative number times negative number, oops, is going to be less than 0. So negative times the negative times negative. We kind of did this with the rational functions too. And so we know that this interval is below 0. Then we can plug in 0. We get 3 times -1 times -2. So that'd be a positive times negative times a negative. Keep it -1. That's greater than 0, which we knew that. And this interval is positive. And then plug in 1. We get positive. We get positive. And we get a negative. So that interval is less than 0. And then this one is going to all be positive. So that's positive. So that's another way to do it. And then you just got to be careful to include the endpoints on there because we have a greater than or equal. But I prefer the graph. If you prefer this way, that's fine too. Either way is fine. And really, I mean, it'd be good to learn this way in calculus. When you get to calculus, you'll probably need to use this way on some things. So it's a good method for doing this too. All right. So this one, 4x cubed minus 25x squared plus 36. Let's factor that. And I actually kind of worked this out beforehand. So this is 4x squared minus 9 and x squared minus 4 less than or equal to 0. And then notice these are both difference of squares. So this would be 2x plus 3, 2x minus 3. This would be x plus 2, x minus 2. And so I'm just going to do the graphing method here. And so we have x is plus or minus 3/2, and x is plus or minus 2. So those are zeros, all multiplicity 1. So we're just going to be crossing every time. And so we have -2, -3/2, 3/2, and 2. And then the y-intercept is going to be 36. If you want to put that, you don't really have to, but we can see playing 0 for the x's, we get 36. So now this one, we're going to be looking at where is it below or equal to the x-axis. And so we have an even degree, we have a positive coefficient. So that one is going to look on the ends like that. And so we're going to come down, we're going to come up there, we're going to come down through that one, and then come back up through that. So now where is it below the x-axis between those two places? So -2 to -3/2, both with brackets because we had the equal part, and then 3/2 to 2. And that is it. All right, so that's polynomials. We will look at the rational functions on the next one.